Oh, welcome everyone. Today we will have the PhD defense of, I have to read your name, Wei Cheng Tan from Malaysia. Correct? Yeah, that's correct. He did his PhD here in the clinic, supervisor of Dennis Röder. I am the third member of the PhD committee in my department. This procedure. So first supervisor was Dennis Röder here in the first line. The second one was Christoph Scherrer, and the fourth member is Martin Langer. And you will give a 30-minute presentation about the main achievements of your thesis, and there will be a 15-minute public discussion. Everyone is encouraged to ask questions. Any kind of question is allowed. And especially you should ask, because we, after the public discussion, still have time 90 minutes to ask our own questions. Yeah. So, yeah, level of education of the candidates good dream and finally finished. And since the candidate did this thesis here, the Syrian clinic, working closely together with Dennis Röder, of course, Dennis Röder will try to present this candidate with some more personal words.
Yes, everyone, and I'm happy to meet you today. So, I met him first in South Africa quite some time ago, where we went to a conference, and afterwards was an honors project.
It was my master's project. I think you will be a visit. Very helpful.
Yeah, it's 2 weeks getting lizards for performance flights. And afterwards, we ended up here with the scholarship. And the first idea was to do some field studies in Malaysia with lizards, and everything was planned, but then COVID happened and we had to change a lot of plans, but I think it was quite successful. And now he's probably in the next weeks working with lizards again, going to Paris, to Anthony Harold, where he was also the supervisor of the marketplace. So now I'm happy to give the floor to you.
All right. Thanks, Dennis, for the introduction, and Lucas as well. So I think Dennis can tell you guys about my type. The last 4 years I've been working on the effects of fragmentation on herpetofauna in Southeast Asia, from broad-scale responses to fine-scale responses in a ever-changing anthropogenic landscape. So, as we all know, we're facing the 6th mass extinction, where a lot of species are threatened extinction, or 44,000 species under the IUCN red list. And what we know, or we think, is that the main driver is habitat loss and fragmentation. So, what is actually habitat fragmentation? It is a landscape process scale process where you have an expansive habitat that's being transformed into smaller patches and into smaller areas that are isolated from each other, and normally by anthropogenic predators such as agriculture or urbanization. But it is not just that simple. It actually involves 2 different processes. One being habitat loss, which is the loss of area, but also habitat fragmentation per se, when the area stays constant, but we have more habitat patches, and also the combination of both. A lot of research currently can differentiate between these 2 processes. Hence, I will use separate fragmentation to indicate these 2. So, but how does it affect biodiversity? First one being straightforward species area relationship, where when you have a small area, you have you're less able to cover more species. When you have a bigger habitat patch, then you can cover more species, and when it's less, then you have less species. And second being isolation effect, where you have habitat patches isolated to each other, between each other, and you have lower connectivity, meaning species are not able to disperse between habitats, and this would affect gene flow. And the third one to know is species respond differently to habitat fragmentation. So, for example, you have more habitat generalists such as pigeons or rats tend to do better when habitats are fragmented, or the probability of occurrence of species are more fragmented landscapes. And you have more forest specialists that prefer habitats where there are more forests. So back to my title, I told you about the effect of habitat fragmentation and what is habitat fragmentation. And I will specifically here my thesis on herpetofauna, which is epipon in Greek. And that includes amphibians, frogs, toads, salamanders, and so on, and also reptiles such as turtles and lizards. And they're highly diverse, but also highly threatened at the same time. So over 40% of amphibians are threatened extinction under IUCN list, and over 1/5 of reptiles are threatened. So for part 2 and part 3 of my thesis, I will focus on turtles and crocodiles, especially freshwater ones, because as you know, freshwater ecosystem only consists of 1% of the surface of the world. And if you look at the ecosystems across the globe, you see here that species threatened on the y-axis, that across reptiles, crocodiles and turtles are highly threatened in forests and wetlands, which are freshwater. You can see here turtles also threatened across all ecosystems. So when you look at turtle species distribution across the globe, here I show you a map of where blue mean less species richness and red meaning more species richness. And you can see that South Asia is a hotspot for turtles. But at the same time, they are highly effective. So if you see the map on the right, the redder they are, the more threatened species they are. So this is why I focus on South Asia, where species are being threatened by agriculture, dam constructions, and so on. So to bring you through the goals or the workflow of my thesis, first it will be 3 parts. The first part is the review, which is a literature review of the harvest research on habitat fragmentation to see whether there's geographical technical biases, and also what other research directions. And then this would be a base for my second and third part to see what are the knowledge, what are the gaps to be filled. And this brings us to the second part, where I look at the broad scale responses of habitat fragmentation, specifically in South Asia, looking at populations of freshwater reptiles, whether they're fragmented or not, and also specifically what other protected areas sufficient to conserve. And the last part, looking at more fine scale responses, where I address some of the limitations in broad scale responses, models using broad scale responses, and using a case study of logging effects of the freshwater occurrences. And now to the part 1, where it's a literature review looking at geographical and external biases and research directions. So when we look at conservation studies, you could see that they are very concentrated in North America, in the global North, such as Europe as well, but also English-speaking countries such as Australia, and also South America and Central America, but very, very few has been concentrated on Asia and Africa. So I want to know whether this bias exists in habitat fragmentation studies, and also if there is any from the bias. At the same time, I want to know how research is conducting their studies, what sort of methods they're using, compare the types of fragmentation or measured responses, and whether this combination of methods are distributed heterogeneously across the globe, or whether they are more homogeneously distributed. So I went thoroughly in Web of Science, from the first possible literature to the last possible literature, spanning over 30 years. And using a comprehensive search query, and I was led through 1,654 papers. And from these papers, I used a standardized Prisma guideline for systematic review and removing duplicates. And then I access carefully the articles one by myself, and only take only the papers that fit the criteria in study. And from this, I got 700 papers. And from this 700 papers, I extracted the location study site and also the genus and species. And this is what we got. So this is a map across the globe where you have the circles representing the location of study site. And you can really see that it's highly biased in North America and Europe, both in reptiles and amphibians. What I want to show you here are the proportions of species represented in studies compared to known species, represented by the grayscale map here. So the darker the continents are, the more species are represented. So you can see that, for example, Europe has over 7% of amphibians being represented, but actually, whereas Europe has only 2% of the species spread across the globe. And when we look at taxonomy of the family, you can see that white turtles, for example, is highly concentrated here, and pond turtles are overrepresented in these two places. And then you have families which are almost not represented at all, in Termotobinidae from Andean mountains, and also a lot of the families from the pastoral snakes and reptiles, such as blind snakes. So several reasons maybe is that one, new species from these families are discovered every year, and we should tend to focus on more well-known taxonomy groups and not critical species. So I also carefully categorize these studies in forms of fragmentation, such as agriculture, urbanization, sampling methods, genetics, and tracking methods, and so on, and also response variables such as the boundaries between the treatments. And I analyze these categories in R using multiple correspondent analysis, which is what's best for categorical variables and what's like ECA. So after that, I use hierarchical clustering on the principal components and visualize them in the diagram and fragment. So you can see that there's actually there's three groups of methods or combination methods, which I will call research agendas. And now you have agenda 1, which is the main and dominant ones, because they're easy and easy to quantify and measure, which is the individual species response, such as richness, presence, abundance, functional research, and so on. And we also have agenda 2, which is on physiological requirements and movements, such as direct tracking methods, experimental fitness, species. And the third agenda population and genetics and modeling, so genomes, population, and prediction models. So when this is the same map that I showed you with the proportion, but here the circles represent the location study site for each research agenda. And you can see that there's no really this huge distinct spatial pattern across the globe. So researchers in the positive levels, researchers are sharing knowledge and methods. But the lack of studies in the global south could actually limit this pattern. But when you remove the first and second agenda, I wanted to show you here that there's a huge lack of studies in the third research agenda, which is genetics and modeling, especially in Asian Africa. This is probably because there's a lack of facility, lack of funding, and expertise for up-to-date methods. So, to synthesize here, relations are bias, geography, and taxonomy. There are relationships between sampling methods and responses, but not at their fragmentation. And research agendas are distributed homogeneously. but I was limited by English search terms. So there are quite a few literatures that might actually affect results. And I identified promising research fields and geographical areas as guideline starting point to incorporate genetics and monopolism in the global south, which is what I concentrated on the part 2 and part 3. So part 2, where I look at Southeast Asia as a study region, and where the populations are from. So I picked some of the so these are some of the study species, and 3 of them are in the top 25 endangered turtles. 2 of these are terrapins, real terrapins, and in the soft turtle field. But also I included some of my cohort projects on the crocodile. So the monkey crocodile, and so the Philippine crocodile, which is the most highly threatened in the world. And I aim to identify what is the environmental factor is related to the species occurrences. And I want to know what are the potentials of the range to see whether populations are fragmented or not. And I want to know also whether these areas are in IUCN reserve and whether which IUCN reserve should be prioritized. And also especially for climate change. So just to give you a quick workflow of part 2 here, I use species distribution model where I collected a current record of direct sampling biases with spatial correlation. And I remove select predictive variables by removing the related ones using check-out approach. And I fit the model with 10,002 absence within 200 kilometers species range, using maxent with 100 bootstrap replicates, using 90% training data and 10% testing data. And I evaluate the model with alpha and TSS. And then I will project and map these model predictions to different spatial and temporal scenarios, such as IUCN reserves, and also water cover surface, which is important for vessel reference. So this is the first paper where I look at the 3 different turtles, but I'll show you the result of 1, which is the product of volumetrics. And just to show you here that the points here represent the species occurrences, and the yellow here are the species frequent ranges, and the polygons are the IUCN reserves. So after conducting SCMs, species distribution models, the mean temperature of the brightest quarter was the variable that contributed the highest to the model prediction, and you could already see that populations seem to be quite fragmented across its distribution. So blue being the highest suitable area and yellow being the lowest suitable areas. But this is not enough. I want to look at what are the protected reserves, how are the conserving systems. So I could set over 2,500 reserves, and I'll take what are countries, total reserve area, and suitable areas. And I looked at here, I show you the proportion of suitable areas in the reserve, where red is the highly suitable ones and yellow is the less suitable. And you have you can see that protected areas are not connected at all. And specifically, I want to know what are the proportion of suitable water area by reclassifying the water surface cover to only include freshwater systems such as river and lake. And you can see that there's way less suitable protected areas in this regional study. And in the end, I recommended 10 top ranking suitable reserves for future conservation efforts. And I did this for also the 2 articles assessing over 6,000 reserves and also 22,000 reserves. Yeah. And just to some of the co-author papers that I did with Rebecca's team and also the collaborator from Iran on the 2 crocodiles, including inclusion of migrant habitats, such as wetlands, human predators, and climate change. If you want more details, we can talk about this later. So compared to the original distribution, this species does not have much suitable habitat than previously thought, especially when you account for areas that are covered by ice and status. But I was limited by some of the studies that are with low sample sizes, which might affect reliable estimates. And I was also affected by, or was also limited by imperfect detection, where species, so SDN assumes a perfect detection, and sometimes there are places where species are not observed, but in reality they are there, so they are occupying the place. So this is called imperfect detection. So I proposed some of the priority conservation reserves where species could potentially occur, and for future surveys and conservation. So now to the last part, where I address some of the limitations of the models in the part 2, and using occupancy model in logging effects in freshwater flows. So Borneo, as you know, has experienced a huge reduction of forest loss, especially related to plantation and also logging. So almost 50% of forest is lost. And here I focus on studying Sabah, Malaysia, and particularly in the Merauke Forest Reserve. It's a beautiful area, but at the same time, commercially low. But here they actually use a sustainable harvesting technique called reuse technology, RL, which imposes strict harvesting guidelines and has proved to have 50% less damage compared to conventional log forests, and has proven to maintain biodiversity. So I want to know what are the impacts of ecological covariates on the effectiveness of turtles, and how do habitat logging and associated covariates affect the occurrence of the turtles, and what are the consequences of the turtle within the reserve. And I look at 2 different species here, the Plantinota and the Remus star. So some it's a collaborative of mine, now Dr. Samesa, collected the data here in the reserve, going to 3 locations between March until July 2019, through 8 different virtual encounter survey sites. And they obtained 82 subplots within the 8 sites. So here I use occupancy models, which compare to SEMs, as I was mentioning. They do better with imperfect detection because they do repeated surveys. So, and here I collected detection covariates, such as rainfall, lunar phases, temperature, and humidity, and also logging covariates. So, what are the responses of historical logging? Such as forest height, stream covariates, time since logging, and distance from logging mode. So first I prepared the data by standardizing the covariates, removing correlated variables, and include random effect to account for nested spatial effect. And then using the species occupancy model, using the UBMS, which is data-based, and using the top priors and the standard approach of 10,000 populations with 5,000 experiment, and also accept for model convergence. And with this model's occupancy model, I made 6 models for each detectability covariate to find out what is the optimum detection covariate. And let's say that's the humidity. And I would combine or add this optimum covariate to 5 models for each logging covariate, including allowance, to find out what is the top model for prediction for the best optimum covariate. So here are the results for detection, and So these are the results for two species, where you see the x-axis are correlated with rainfall, and we have detection probability on the y-axis. And you can see that the more rainfall you have for both species, the less detected pearls you are. So this could be due to nesting behavior, where there's less rainfall, there might be more available nesting sites because of the exposed banks of the river. So possibly that makes it more detectable. So, and then when you look at occurrence probability, first we have distance from road here for Reptiles platinota, and further away you have from distance from road. It seems like the more occurrences probability you have. And this is the same for flow accumulation. So the more flow accumulated flow you have in the river, with the problem of river size, the more occurrences of this flow are. Now for the other species in Proganas plana, the results were quite good. So to synthesize, this is one of the first studies that focus on the effect of reduced impact logging on occurrences of freshwater flows. And I thought whether conditions are essential for reliable estimates. And platinota occurrences are higher in larger streams and further away from logging roads. But one of the huge limitations here is that there was no comparable site. So future surveys could be conducted for conventional log sites or primary flow sites for comparison. So, what are the take-home messages? So I did a review showing you what are the geographical and taxonomical biases in the features that we have, and I showed that there is a bias, and also that the lack of bias in the global south of the dynamic model. And using the result here or the knowledge here, I use distribution models to find out whether populations are fragmented in Southeast Asia, looking at raw field quantities, and to see whether ICF detectors are effective or not, and actually they are in the current state. And then addressing some of the limitations from our tool, using occupancy model to see whether logging affects soils, and I so that whether conditions play a role in affectability and soils, and also soils are going further away from logging roads. So I would like to thank my community, especially Dennis Roder. This is the picture where he got one of my visits in South Africa. And then I'm pleased about we have a piece of further here, Lucas Fiber, and this is one. And this project or this thesis would not be possible without the support funding of the RD and the Imperial, and also with my collaborator here, but also really I would not be standing here on, so I'm really here standing on the shoulders of these many people that have been doing the past 4 years, and I'm proud of that. Thank you.
Well, thank you very much for the introduction of your thesis, and it is open for questions. Please ask questions. Yes.
Thank you.
So with the last one, you used in and
Yes.
I'm afraid I didn't get the connection to the current methods. Like what makes reduced impact logging different from conventional logging, and how are the effect of the terms that you were speaking about classification and this, but I didn't.
Yeah. So so the detections probability or detection curves. Sorry, the detection estimates are mainly to find out what the curves are. It's basically a hierarchical model where you have to find out what what are the best detector covers are for, to find out what is the best detector coverage. And now to the question on RLL, or the reduced impact logging. Unfortunately, yeah, this was one of the big limitations that we have, that there is no comparable sites to find out whether RLL is doing better than conventional log. But we did find out that both are responding negatively to logging roads or logging estimates. Especially one of them, which is the Notachellis platinota, which is one of the critical emergent species. But here I can show you a result where we also found out the occupancy probability was over 0.7 for the platinota, and I think over 0.5 for the Sultana, which is pretty high compared to the other species occupancy found in this result. But this is, yeah, like we're limited of what we can say, but yeah, this is sort of just the first study that we want to know in this result, so that we can maybe inform the forest managers how to better manage this total population. So with the RL guideline, they actually make a logging road so that they are on ridges, so that they can prevent less soil erosion and sedimentation. And they also have a buffer zone with riparian areas. I think it was at least 30 meters. And I can look it up again. Yeah.
Yeah.
Okay.
Thank you for your talk. I have a question about the second part of the project, where you gather distribution records. And I wondered how far, like, what is the source of the distribution records, which is published before?
Wait. Yeah, so you need species presence or the distribution range?
The distribution range.
Okay, so this was so for the turtles, especially this is from the one of the collaborators, so I think the conservation, the Turtle Conservancy, also the Turtles Foundation, and they are actually turtle experts, and they are the ones who collected all those species spread record, and actually the records are also filtered by turtle experts that are in that area, like the turtle experts that are for this species as well. So we can quite safely say that distribution ranges are pretty correct. Yeah. Yeah. So no.
Thanks, Tim. Dr. Presentation question about the part one.
Yeah.
Your systematic review. You presented that personal diagram where you first found like 1,600 papers.
Yeah.
And then you down to like 600, 700.
Yeah.
And then part one excluded.
Yeah.
And you said with reasons.
Yeah.
And what were some of the reasons that you excluded?
Yeah, sure. So I think there were some. Okay, so we want to know there's quite a few reasons or criteria. So first being whether they have any data on, or whether they collected any data empirically, and also whether they are fitting the categories that I'm using. So they are fitting into my study. So whether they use some of the response variables or the methods that I was looking. Yeah. I mean, there's also several other reasons, but the seven ones that actually exclude most of them. Yeah. And also some of them actually you could even find papers of plants and totally unrelated to the taxon that was. Yeah.
I've got a question for the second paper. Where you consider this distribution rate, so people asking about almost only the coastlines, and almost none of the protected areas is at the coastlines. Do you know any reasons for this? Because from a very naive point of view, it doesn't make any sense. We have so many species in the coastline, right?
Yeah, well, very obviously, human development are very concentrated on the coastline. So that's why we have less protected areas, especially I can go back, but, especially in the coastal areas, for example, in Peninsula Malaysia, those are very populated. And, actually, that's very fun because, some of the soils are very, concentrated on, estuaries and backwaters and mangrove areas. And these are really, habitat species, but yeah, probably. Yeah, so much, particular areas in this place.
Yeah.
That's just not good at, follow up on this. I was just wondering regarding motility and action.
You mean along the coast as in seawater? Or so yeah, that's a good question. So the three species are actually there. I think I'm just kidding. Because the three species are actually there. One of them is can tolerate saline concentrations. So for this one, oops. So the soft development will have, they are known to tolerate seawater. So I assume that would be possible with them. But for the Thesis and the other one, Guanensis, I don't think they actually can move through the sea. No. Well, one of them, sorry. So there's very, very few diseases on them, of course. And for the Guanensis, they are found to actually nest on beaches. And one experiment from the 1800s or something, they actually found that they can tolerate up to 2 weeks of saline water. They could, yeah, in these 2 weeks, it is doable, yeah. Yeah, quite good. Honestly, yeah.
Yeah.
So one of the key takeaways from me, for the second part of your project, was I see right? And at least from the lens of the species, so the debate proposal behind CN for taxing conservation, only ability to follow species specific model to designate the protected field for. What would your proposal just?
Yeah, definitely. So I guess the optimal way is to have more protected areas, especially in the places where there's more suitable habitat. Of course, also trying to know whether some of the suitable areas do actually contain species, so actually going down there and doing population surveys. So that's one, but some of these protected areas are also needs to be managed differently because each country has their own legislation. So some protected areas could be due to could be affected by logging, for example, or there are different ranks of protected areas where and definitely also trying to enforce that. Yeah. So yeah. Definitely adding more protected areas and also having more connected protected areas as well. That's quite important.
Those are questions?
I think from research in insects, it really responds to logging and these kind of ideas of reduced impact logging. There's been kind of an idea of riparian reserves where you can kind of like channels no logging along rivers, and that allows kind of these connections between habitats and are associated with fresh water. Is that something that you saw with the first study area?
I would say not directly, but indirectly, this comes back to the same question that Malin was asking about whether the riparian areas are and are. You'll see that you can. No, it's actually Dennis' phone, I think. It's iPhone. Yeah.
You also considered the presentation to the internet? It was hybrid here?
Yeah, it's hybrid. Yeah.
So
that's-
maybe another question from the.
Oh, yes. Yeah,
No,
I was checking as well.
well.
No, I already started to check, but I think there isn't. There was only yeah, messages from before. So guys, if you have any questions, just go for it.
Here's another question.
You mentioned one slide where you show the model potential range and the actual delineation. And there was one spot in the very directly below the Malaysian peninsula, where there were extremely high model suitability but no occurrence. So I was wondering, does it occur in that area or are there computers who leave it there?
Sorry, just in a second.
Yeah,
Yeah,
this small island.
you mean on here?
Yes.
Yeah, no, this is so I think they are protected areas there, but not here. You can see that it's covered. So your question is whether they could reach there or
Are they actually there, or is it just a sampling bias? Or
no, it's not a sampling bias because we don't actually see any well, you can take sampling bias because we not know whether you can see there, and maybe if we go down there and we try and look for it, I think that's sort of the future step. But yeah, here like the white circles here are the present circles, so none of them is sitting there. So potentially, so here what can be concluded is that the climatic conditions are right for this sort of thing.
Can we put it down? Otherwise, thanks for asking so many questions. Thanks for listening, and we will continue like in closed sessions.